In this episode, we're going to make the secure software lifecycle feel less like a corporate slogan and more like a practical way of building and changing systems without constantly creating new security problems. Most payment environments rely on software, whether that means a website, an app, a point-of-sale component, an internal service, or a set of scripts that glue systems together. The moment you accept that software is always changing, you also accept that security has to be built into how change happens, not bolted on at the end when it is too late and too expensive to fix. New learners sometimes imagine security as something separate from development, like a final inspection, but a secure lifecycle is the idea that security gets handled in every phase, from planning to design to coding to testing to release to maintenance. The phrase that delivers is important because the goal is not to slow everything down until nothing ships, but to build habits and checkpoints that help teams ship confidently and safely. When done well, the secure lifecycle reduces surprises, reduces emergencies, and turns security into normal engineering discipline. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good place to begin is understanding what a software lifecycle is in simple terms. It is the path software follows from idea to reality and then through ongoing updates. You start with requirements, meaning what the software is supposed to do and what constraints it must obey. Then you design how it will work, you implement it, you test it, you deploy it, and you keep maintaining it as the world changes. Every one of those steps creates opportunities for security to be added or lost. For example, if security requirements are missing at the beginning, developers might build a flow that collects too much sensitive data or stores it in risky ways. If design ignores threat scenarios, the architecture may accidentally make attackers' jobs easier. If coding practices are sloppy, vulnerabilities can be introduced through mistakes that are hard to spot later. And if deployment is rushed, configuration issues can expose even strong code. A secure lifecycle is the commitment to treat security as a first-class requirement, not as a cleanup step after the fact. One of the most important early ideas is that secure development starts with deciding what data should and should not exist in the system. In payment contexts, a lot of risk comes from collecting and handling cardholder data when you do not actually need to. If the business can design the system so that sensitive values are handled by a specialized payment service and the rest of the application only sees tokens or limited references, that single decision can reduce scope and risk dramatically. Beginners sometimes assume software must touch the full card number because that is what payments are, but modern designs often avoid that. The secure lifecycle encourages teams to ask these questions before building anything, because if you design around minimal sensitive handling, you avoid many downstream security burdens. This is why requirements and architecture discussions are security activities, even though they do not look like security tools. Good lifecycle security begins with smart design choices that prevent entire categories of mistakes. After requirements, threat thinking becomes the bridge from what you want to build to what could go wrong. You do not need to be a seasoned attacker to understand the basic principle. If the system has an input, someone can try to abuse it, and if the system has a privilege boundary, someone can try to cross it. Threat thinking means asking, for each major function, what an attacker might try, what mistakes users might make, and what failures might happen under stress. For a payment web application, that could include questions about unauthorized access, data leakage, manipulation of transactions, or abuse of account recovery flows. For an internal service, it might include whether one compromised system could call privileged functions it should not. The goal is not to invent wild science fiction scenarios, but to identify plausible risks early enough that design can address them. When teams skip this step, they often end up patching vulnerabilities repeatedly because the architecture itself made risky choices. Secure coding practices are where many people think the lifecycle begins, but in reality, coding is the middle of the story. Still, coding matters because implementation errors are a common source of vulnerabilities. A secure lifecycle expects that developers follow standards that reduce common mistakes, such as validating inputs, handling errors safely, and avoiding risky patterns that can lead to data exposure or unauthorized actions. For beginners, the key is understanding that secure coding is not about being paranoid. It is about being disciplined and consistent. It also includes using dependable components and libraries responsibly, because modern software is assembled from many dependencies. If you rely on a vulnerable component, your software inherits that vulnerability. So part of secure coding is knowing what you are using and staying current with updates. This is why a secure lifecycle treats dependency management as a security function, not just a convenience for developers. Testing is the next area where a secure lifecycle proves whether it is real or just a document. Security testing includes checking that security controls behave as intended and that vulnerabilities have not slipped in. It can involve automated checks that run during development, as well as deeper review before release for high-impact changes. The key beginner lesson is that testing should not be a single big event right before deployment, because then the only choices are to ship with risk or delay everything. A lifecycle that delivers uses testing continuously, so problems are found early when fixes are smaller and clearer. It also means testing is tied to the actual threats and requirements of the application, not random generic checks. For payment-related software, this includes ensuring sensitive data is not logged, not stored unnecessarily, and not transmitted without protection. Testing is where you turn design promises into evidence. Change control is a major part of the secure lifecycle because most security incidents are not caused by a system existing, but by a system changing. A new feature introduces a new endpoint. A configuration change opens access. A rushed hotfix bypasses checks, or a debug setting remains enabled. Change control means changes are reviewed, approved, and tracked, so there is accountability for what moved into production and why. This does not have to be a heavy bureaucratic machine, but it does need to ensure that risky changes receive appropriate scrutiny. A beginner-friendly way to think about it is like building codes for a house. You can remodel, but you do not knock out support beams without checking the structure. In a payment environment, one poorly reviewed change can create a data leak that persists for months. A secure lifecycle that delivers makes change safer by making it visible and governed. Deployment and configuration deserve their own attention because even perfect code can become insecure when deployed badly. For example, leaving default accounts, exposing administrative interfaces, or misconfiguring network access can turn a secure application into an easy target. The lifecycle approach expects secure defaults and controlled deployment practices so environments are consistent and predictable. Predictability helps security because it reduces unknowns and makes monitoring meaningful. Beginners often assume deployment is purely an operations concern, but security relies on how systems are actually run. If development and operations are separate worlds with no shared security ownership, important details fall through the cracks. A secure lifecycle encourages shared responsibility, so security requirements survive the journey from code to running system. The goal is to ensure that what was tested is what is actually deployed. Maintenance is where many lifecycles fail because teams ship software and then treat it like it is finished. In reality, attackers evolve, new vulnerabilities are discovered, and the environment changes around the software. Maintenance includes patching dependencies, rotating secrets, updating configurations, and responding to new threat intelligence. It also includes removing features or data paths that are no longer needed, because in-used code and in-used access are risk magnets. A lifecycle that delivers treats maintenance as part of the product, not as an afterthought. That means planning time for it, measuring it, and treating security updates as normal work. For payment environments, consistent maintenance is critical because outdated software is a common target and attackers often scan for known weaknesses. When maintenance is routine, emergencies become less frequent and less severe. A secure lifecycle also depends on clarity about roles and accountability, because security tasks that belong to everyone often belong to no one. Someone must own security requirements. Someone must ensure threat thinking happens. Someone must ensure testing is meaningful, and someone must ensure changes are controlled. That does not mean one person does everything, but it does mean responsibilities are defined and supported. Beginners sometimes assume processes run themselves, but processes only work when people have the authority and time to carry them out. This is where governance intersects with development, because governance sets expectations and ensures teams cannot quietly skip steps under pressure. A life cycle that delivers balances flexibility with discipline. Teams can move fast, but they do not cut corners on core protections. When accountability is clear, the organization can improve over time instead of repeating the same mistakes. It is also important to understand what evidence looks like when you claim to run a secure software lifecycle, because this is where assessment mindset enters. Evidence is not just a statement that developers care about security. It is proof that security activities are embedded in the lifecycle. That can mean documented requirements that include security needs, records of reviews, results of testing, and change records that show what was deployed. It can also mean policies and standards that define how development is done and how exceptions are handled. For beginners, the lesson is that maturity is visible in consistency. If security steps happen only when a particular person remembers, the lifecycle is fragile. If security steps are built into how work is done, the lifecycle becomes resilient, and the organization can scale without losing control. A final teaching beat is understanding that the secure lifecycle is not meant to eliminate all risk, but to make risk manageable and transparent. Software will always have bugs, and people will always make mistakes. The secure lifecycle is how you reduce the number of mistakes that become serious vulnerabilities, and how you catch issues before they reach customers or attackers. It also provides a way to learn from incidents and improve the process, so you do not keep repeating the same failure modes. When teams treat security as a life cycle, they can respond to new threats with updates that are controlled and tested rather than frantic and risky. This is how you deliver software that evolves safely, instead of software that becomes a fragile liability. Over time, this approach builds trust, because stakeholders can see that change is handled responsibly. As you tie all of this together, running a secure software lifecycle that delivers is really about building security into the rhythm of building and changing software. You start with requirements that minimize sensitive handling and define clear security needs. Then you design with threat thinking so the architecture resists common attacks. You implement with disciplined coding and dependency management, and you test continuously so issues are found early. You control changes and deployments so production reflects what was intended and reviewed, and you maintain consistently so software stays resilient as the world changes. You clarify ownership so the process does not depend on luck, and you collect evidence so confidence is based on reality. When you adopt this mindset, security stops being a last-minute obstacle and becomes part of delivering reliable systems, which is exactly what payment environments need.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.